So you believe that 50% of Americans have watched the Super Bowl this year. And so that means your null hypothesis is the probability equals to 50%. So you conducted a survey and you found 202 out of 400 have watched Super Bowl this year. What is the p-value? First, this is a binary distribution. You watched it or not, right? So when you believe that the probability is 50%, this implies the variance is p times 1 minus p, which is 0.5 times 0.5. In other words, that means standard deviation is square root of variance. So it is square root of 0.5 times 0.5, simply 0.5. So standard deviation is also fixed by the null hypothesis. Additionally, the sample size is 400 and the sample mean equals the sample probability, right? Because it is binary. So in your sample, out of 400 people, 202 have watched the Super Bowl this year. Okay, now you're ready to calculate the t-statistic. The t-statistic is x bar minus mu 0, which is the difference between the theta and your hypothesis, and divided by the standard error, right? We are ready to plug in all the numbers. Right? We know all the numbers. So this is 0.505. So that is coming up here, 505 minus your hypothesis is 0.5, standard deviation is 0.5, sample size is 400. Okay, so you can calculate them. Then you will get a t-statistic of 0.2. T-statistic 0.2 means in the standard normal distribution, t-statistic follows standard normal distribution, but your realization is 0.2, slight above the center, right? And then the p-value means the area outside of the observed t-statistic. But at the same time, you are going to consider the same error on the other side, so you have to include this probability too. That means the p-value equals probability. The standard normal distribution is smaller than minus 0.2 plus normal distribution greater than 0.2. So if you calculate them, you will get 84.14%, which is a huge p-value.